Hey guys, today we're going to be talking about the states of matter. And there's three states: solid, liquid, and gases. The first one we're going to look at is a solid.
This is frozen carbon dioxide, or dry ice. Dry ice is not water, it is frozen gas, carbon dioxide. Carbon dioxide gas freezes at a temperature of 109.3 degrees below zero Fahrenheit. That is extremely cold. Cold enough to make copper scream. Kendall, can you put the lids on these two, on that one? No, the lid on this one. So what we're examining here is the rate of sublimation. And dry ice sublimates at a ratio of about 10 to 1, which means if I were to take a block of dry ice that weighed about a pound, and I put it in a tank of water that had really, really high walls, that fog that you see there would fill that tank about 10 feet above the surface of the water, because it takes up about 10 times more space. Kendall, why do you think these lids will not stay on these cans?
Because the gas is trying to escape.
Thank you very much, Kendall.
That's pretty cool. The neatest thing about dry ice is you can buy it at the grocery store. Alright, the next thing we're going to look at is gas.
We've got hydrogen gas. We're going to talk about different densities of different gases. So we've got three different gases.
Gotcha.
Hydrogen's our first one. So here's your beach ball. I'm going to open this up.
Okay.
What I want you to do is just kind of squeeze it and really just let it go, because we need a lot of gas to get in that.
Squeeze
so
the
we're going to
beach
make some
ball?
bubbles.
Okay.
You're familiar with hydrogen?
Yes.
Hydrogen is lighter than air. It's about 14 times lighter than air. So
Is this working? Am I doing
it's
what
working. It's
Is this
working.
the experiment? We're
So-
making bubbles?
Well, eventually those bubbles are going to start to get so light full of that gas that they're going to start to fly up to the ceiling. And I've got a candle. You remember the Hindenburg? It didn't end well for the Hindenburg. So we're going to see how well we do tonight.
Wow.
We did pretty okay. We did it pretty okay. But we're at the Museum of Discovery. We're hands-on. So
No, be careful.
We do it
Be careful.
hands-on.
Kevin, no, be careful.
So we're okay. Oh, look at this. Isn't this amazing?
This is sad. What is it?
This is a tank full of gas. There's sulfur hexafluoride in there. So hydrogen's lighter than air. Sulfur hexafluoride is a lot heavier than air. So let me show you.
Sulfur hexafluoride.
Yeah. The first thing I want to do, I got some dry ice here.
Okay.
So here, I'm gonna take this off, and yeah, there you go. Watch what happens. So I'm going to pour some dry ice. You know dry ice, right?
Yeah.
You get a lot of fog. So I'm just going to pour some over here, and we'll see what happens. I poured a little bit in there. That's okay.
Hey.
Wait a second. Something's going on in there.
That's cool.
So let me give you something here. I got this boat. See if you can float that in there. Just kind of
Float your
put it on
boat,
the top.
Jimmy.
Yeah, float your boat. And I'll make it like Scooby-Doo. You know, kind of spooky. Now just give that a little sail.
Wow, that's
Isn't that
amazing.
fun? That's pretty cool. Silver hexafluoride. It's also non-toxic, so you can breathe it in. So
Oh,
here,
thanks for telling me that now.
here's one for you, and Lucy, I've got one for you too. There you go. So you can go ahead and breathe that in. I've got some helium. You know helium you can breathe in too. What
Yeah.
happens when you breathe in helium? You remember?
Your voice goes high.
That's right, because it's a lot lighter than air, so all the sound moves really quickly through it.
So if helium makes your voice sound higher because the molecules move faster, what do you think will happen if the gas is heavier and the molecules are slower?
Yeah, right on. Oh man. There you go. So, yeah, right.
That's pretty cool. Next thing we're going to talk about is liquids.
So water is a liquid, obviously. Water boils at a temperature of 212 degrees Fahrenheit. Now, boiling doesn't mean hot. What boiling means is that once it's reached the highest temperature it can reach, a liquid starts to change. It starts to vibrate crazily and bubble like crazy and evaporate, right? So not all liquids do that at the same temperature, and nitrogen, which makes up about 80% of the air, in its liquid state actually boils at 321 degrees below zero, which is really, really cold. So Kendall, I'm going to put my gloves on again, and I'm also going to put on some goggles to protect my eyes. I mean, I'm wearing glasses, but that's just so I don't bump into stuff. All right, so. So now, Kendall, can you see there is a liquid in this pot?
Yes.
Can you see that it is boiling, or appears to be boiling?
Yes.
What do you normally do when you have a pot of boiling liquid on your stove at home?
Spaghetti.
You put spaghetti in it. We don't have any spaghetti. What we have, though, is Cheetos. Okay? Do you want to have a Cheeto? All right. So I have some Cheetos here. These are laboratory-grade Cheetos. So once I put them in the liquid nitrogen, what I'm kind of doing to them is frying them, except, backwards. So deep freezing or freeze frying. I don't know, whatever you want to call it. Now, what we're left with, though, is a really, really, really cold Cheeto. Kendall, do you think it would be safe or smart for a human being to eat this Cheeto?
Absolutely.
I'm gonna have another one. Kendall, you want one?
I do.
All right. So Cheetos have a lot of holes in them. And since they have all that surface area, there's an awful lot of space for all that liquid to go. But that liquid's going to just evaporate, right? So it super chills the Cheeto, and what you're left with is something really, really cold that you can eat. So go ahead. You just want to avoid letting it touch your lips, just to your teeth. Very good. Don't get Kendall angry, because she does that sometimes. Okay. All right, Kendall, how many balloons do you think we can fit in this pot?
I have no idea.
All right, there's some balloons around here. Can you hand me some balloons? So if you like going outside on a cold day and you forget your coat, you probably know what it looks like. Kendall, what do you do when you forget your coat and it's really, really cold outside? What do you look like if you've gone outside and you're not wearing a... Yeah, right. You're going like this. You're making yourself really, really close together. So as these air molecules get super, super cold, they condense just like that. They get themselves really, really small. And they actually condense into a liquid, which does not take up as much space as a gas does in this particular balloon. So all of the gas in there has now condensed into a liquid, and so it doesn't take up any room at all. So our balloons can fit all of them in this pot. But as those air molecules start to warm up, they expand again, as warm air tends to do. And so what we're left with are balloons that kind of, well, used to be sort of dead, and now are reflating themselves. Reflating, is that a word? I made up a word. That's okay. Shakespeare did it. All right, so now our balloons are starting to reinflate themselves. Now, Kendall, would you agree that this is pretty awesome science?
Pretty awesome.
Thank you very much. Awesome science is science. That is awesome.
Wow, that is some pretty neat science. Special thanks to Kevin Delaney for all of his awesome science videos that I found on YouTube, and I hope that you guys have learned something new about the states of matter. Thanks again.